Welcome back everyone, Patrick here, moving on to another factoring video. We have to factor each of these expressions over here. So notice in this particular case, we are dealing with multivariable expressions because there's two variables in each of these expressions, an x and a y, and sometimes you may run into these kinds of examples. We went over other multivariable factoring in the previous section when this a value here was 1, but notice here in this case the a value is not going to be 1. But the same thing is going to apply. We're still going to be using decomposition. These aren't quadratics, but you still want to treat this as the a value. This would be the b value. That would be the c value. So let's write out this first one over here. So we got 4x squared plus 13xy plus 3y squared. So first thing we always check for, can we take out a greatest common factor? Notice between 4, 13, and 3, can't do that. And then the variables, notice there's two x's here, but then there's no x in this expression. So we can't take out an x variable because it's not common in all the expressions. And then the y variable, it's in these two expressions, but it's not in that one. So we can't take out anything in terms of y. So let's see if we can factor this with decomposition. So first thing we do, we write out the a, b, and c value. Then we take the a and the c, multiply those, so that would be 12 in this case. And then as usual, we want to find two numbers that multiply to that ac value of 12, add up to that b value of 13. And those two numbers would be what? 1 and 12? Right? 1 times 12 is 12, 1 plus 12 is 13. So then you take those two numbers and you decompose this middle term over here. It's just, you got to remember in this case to remember the xy. Usually this was just x when we were dealing with just quadratics. Now this is xy. So we'd have plus 1xy plus 12xy plus 3y squared over here. And then you just factor by grouping. So from these two, what can we take out? Notice we could take out an x variable. It's common. And so what would we be left with? If we take out an x from all these, we'd be left with 4x plus y, like that, right? If you take this x variable, redistribute it in the bracket, you'd end up with this. To get these values, you could just take each of these terms, divide it by x, in order to see what's left in the bracket. Now between these two, we got a 12 and a 3, so notice that a 3 is definitely going to be common. And then we have a y variable in both, so we could take out a y variable. So what would we be left with? Well, we would just divide this by 3y, divide this by 3y, so 12 divided by 3 is 4, the y's cancel out, we're left with an x, the 3's cancel out, y2 over y1 would give us just y. Like that. And as expected, as we know from previous decomposition examples that we've done, these two brackets should always be the same. So then we could take out that binomial factor and we'd be left with x plus 3y like that. So that ends up being the answer. And as usual, if you want to check your answer, you can expand your final factored expression to make sure that you get the original. So notice if we do that, I won't do it for all of these, but I'll do it for this one. If we multiply everything, notice these are like terms. So that would be 13xy plus 3y squared, like that. And we end up with that original expression. Okay, so you could always check your answer with these as well. It's just when you're dealing with multiple variables, just be careful with your algebra as there's more going on versus if you're just dealing with a single variable. Okay, now let's move on to part B. So with part B, we got 5x squared plus 11xy plus 2y squared. Like that. So notice the a value is 5, the b value is 11, the c value is 2, the ac value is 10. And then multiply, what two numbers? Multiply that ac value of 10, add up to that b value of 11, it would be 1 and 10. Right? 1 times 10 is 10, 1 plus 10 gives us 11. So again, decompose kind of similar to the last one because of this 1 over here. But there are different numbers nevertheless. So from these two, what can we take out? Notice we could take out an x value. Can't take out any numbers because we have a 5 and a 1 over here. So we could take out an x, we'd be left with 5x plus y. And then from these two, from the 10 and the 2, we could take out a 2, and then we could also take out a y. So if we divide this by 2y, divide this by 2y, notice we'd be left with 5x plus y. So same bracket, we could take out that, and we'd be left with x plus 2y like that. So this would end up being 5x plus y, and then x plus 2y. Then moving on to part C, we got 3x squared minus 14xy plus 8y squared. So first thing we always check, can we take anything out between the 3, 14, 8? Can't take anything out, and then we can't take out any variables because there's no variable that's common in all three expressions. So a value is 3, the b value is negative 14, the c value is 8. So let's see if this works with decomposition. So the AC would be 24, find two numbers that multiply to 24, and then add up to that b value of negative 14. And those two numbers would be negative 12, negative 2. Right? Negative 12 times negative 2 gives us positive 24. Negative 12 plus negative 2 gives us negative 14. So this decomposes like that. And then from these two, we could take out a 3x, so we'd be left with x minus 4y, like that. And then from these two, notice there's a negative here, so we're definitely going to take out a negative between 2 and a. We could take out a 2. We could also take out a y. It's going to be common in all of them. So dividing this by negative 2y, we're just left with an x. 8y squared, we could do this on the side even, divided by negative 2y, what we took out, this would be negative 4, and then y2 over y1 gives us y, so this would be negative 4y. And as expected, these two brackets, they're the same thing. So we could take out those two brackets, and we'd be left with 3x minus 2y. So we got x minus 4y, 3x minus 2y, like that. Okay, moving on to part D, we got negative 7x squared plus 15xy plus 18y squared, like that. So first thing, notice that we're dealing with a negative in front here, so I'm definitely going to take out a negative 1 to start as a greatest common factor. Now between 7, 15, 18, can't take anything out in terms of those numbers, and then you can't take anything out in terms of variables. But we could take out that negative, and then notice all of the signs would change like that, right? And so from here, let's just deal with this quadratic separately. Let's see if we can factor that alone. So notice that the a value is 7, the b value is negative 15, the c value is negative 18, right? And so the AC value would be 7 times negative 18, which would give us what, negative 126. And so we got to find two numbers that multiply to that AC value, negative 126, but add up to that B value of negative 15, like that. And the two numbers would be negative 21 and positive 6. Those work, right? Negative 21 times 6 gives us negative 126. Negative 21 plus 6 gives us negative 15. So then we could decompose this into those two values like that. From these two, we could take out a 7x, and we'd be left with x minus 3y. And then from these two, we could take out a 6y, and we'd be left with x minus 3y again. And then we could take out that x minus 3y, and we'd be left with 7x plus 6y, like that. So this, don't forget the negative though in front. Remember that it was this bracket that factors into those two, but we still have that negative for the overall expression. So the final answer would be negative bracket x minus 3y bracket 7x plus 6y, like that. Right? That would be the answer for part D. Now moving on to part E, so we got 25x squared. So let's write this over here, 25x squared minus 15xy minus 4y squared. So exact same process. Can we take anything out initially? 25, 15, they have a common factor of 5, but unfortunately we have that 4 at the end, which doesn't have a factor of 5. And then the variables, there's no variable that's constant throughout these. So we can't take anything out initially. Let's do decomposition. So we'll have the A, B, and C value. Then we multiply the A and the C. That would give us negative 100. So what two numbers multiply to negative 100 add up to that B value of negative 15? That would be, what, negative 20 and 5? Negative 20 times 5 is negative 100. Negative 20 plus 5 gives us negative 15. So then we decompose that middle value into those two values like that. From these two, from a 25 and 20, we could take out a 5. We could also take out an x. So we'd be left with what? 25x squared divided by 5x gives us 5x. Minus, the negative comes down, 20xy divided by 5x would give us 4y. Right? And then from these two, between the 5 and the 4, we can't take anything out, but we could definitely take out a y. And then when we do, we'd be left with 5x minus 4y. Same bracket. We could take out that same bracket, and we end up with those two brackets. So that ends up being the final answer for part E. And then finally, part F. This is another one of those cases where we got a negative in front. So we got a negative 15x squared minus 4xy plus 3y squared, like that. So notice there's a negative here. We're definitely going to take out a negative, but then there's nothing else that we can take out. So in all of these, we didn't really have a greatest common factor that we could take out. Actually, in the next video, we will be taking out greatest common factors from all of the expressions that we're going to be factoring. But in this case, there was only two expressions where we had to take out a negative one, and this ends up being one of them. Like that, right? So let's see if we can, let's actually work with it over here. Let's see if we can factor that term in the bracket. So the A value is 15, the B value is 4, the C value is negative 3, the AC value is negative 45. C, if we have any numbers that multiply to negative 45, and then add up to that B value of 4, like that. So the two numbers would be negative 5 and positive 9, negative 5, positive 9. Negative 5 times 9 gives us negative 45. Negative 5 plus 9 gives us that positive 4. So we'd end up with 15x squared minus 5xy plus 9xy minus 3y squared. From these two, we could take out a 5x. We'd be left with 3x minus y. From these two, we could take out a plus 3y. And we'd be left with 3x minus y as well. Then we could take out a 3x minus y. And we'd be left with 5x plus 3y, like that. All right, so this here would factor into 3x minus y times 5x plus 3y, like that. Oh, actually, sorry. See, you got to be careful. We still have that negative in front, right? Those two brackets was only this bracket over here, but we took out a negative initially. So don't forget that in your final answer. I almost forgot it there, right? It's a common mistake that happens. So always keep your main work. Maybe don't mix up your main work and then your side work in one column like I did over here. Keep your main work here, and then if you have to do some side work, maybe put it on the side just so they can be separated on your page. Right, so that's the process of factoring by decomposition if you run into these sort of expressions where you're dealing with multi-variables.